Hey everyone, welcome to our part 2, our next section with rational equations. So here we're just going to run through a couple of examples. So as before, I kind of recommend that you try each one out along the way and kind of come back and check and see either if you get stuck or you want to check and see if you're on the right track, if you have the right answer, that sort of thing. Just because we're just going to be working through some problems, so they really help you learning them if you're practicing them as well. So for this one, same thing as before, I encourage you that you kind of try it out before we go through the answer for it. So just pause the video, copy down the question, try it out, and then come back if you're stuck or if you want to check and see if you're on the right track. Alright, so we've been going through solving these rational equations, and I'm going to go through the same thing that we did before. So I've got this over 2, and this with a 3 on the bottom, and so I'm going to go through and multiply by these numbers to get rid of the fractions. Now, I can multiply by 2 everywhere, and I can multiply by 3 everywhere, or I can look for the common factor between 2 and 3. Okay, that lowest common denominator here. So, in this case, between 2 and 3, I can see that the first denominator they're going to have in common is going to be 6. So that means that I can multiply each one of these by 6. Remember, it's multiplying each term by the same thing to keep it consistent, which means that that 2 also has to be multiplied by 6. So 6 divided by 2 gives us 3, and so I have brackets here that are surrounding this because that 3 has to multiply each of the x and the 3 inside the bracket. 6 divided by 3 here is 2, and so again, I've got brackets outside, and then I've got my 2 times 6, which gives me my 12. So really here I've got 3, and then x plus 3, I have no more denominator, it's now cancelled out with the 6, subtract, and then a 2, and then x minus 2, and that equals 12. So I need to expand my bracket out. I need to take the 3 times the x and the 3 times the 3. Okay, so it has to multiply each term inside the bracket. So then I'll have 3x plus 9. Now notice this is like a negative 2. So I've got negative 2x plus 4. Negative 2 times negative 2. And that equals 12. Simplifying this, 3x minus 2x looks like I just have an x plus a 13 equals 12. And then after that, I'm going to subtract 13 on both sides to move this over to the other side. So 13 minus 13 is 0, and I have x is equal to 12 minus 13, which is negative 1. Notice here on the bottom, on both terms, there are no variables. So in this case, x can really be any number. It can exist and there's no non-permissible values. So in this case, there's no non-permissible value. There's 2 S's there. So in this case, I can have x be any answer. Okay. The other thing with this is that I have an answer. Now I just need to check to verify that it in fact can be the right answer. So in order to check, that just means that we're going to take our answer and we're going to plug it back into our expression. So in this case, I have negative 1 plus 3 divided by 2 minus, and then back at my original question, negative 1 minus 2. So here I'm going to tuck brackets around my negative 1 just to make it a little bit more clear as to what it is that I'm doing, and divide that by 3, and we're going to check to see if that equals 2. So 3 minus 1 is 2. 2 divided by 2 is 1. Minus 1 minus 2 more is minus 3. And I'm going to be dividing that by 3, and we're going to check and see if it equals 2. So really what we're saying here is 1 plus 1, right? Negative 3 divided by 3 is negative 1. Negative 1, or 1 subtract to negative 1 gives me a positive 1. Does that equal 2? And yes, it does. 2 equals 2, so we know that this checks out to be the right answer. So there's our example 3. In our next example, it says we start to kind of get into this idea of kind of word problems where it might require you to think a little bit outside the box. So the sum of 2 reciprocals of a value, two consecutive integers, is 11 over 30. And I want to say, what are the integers? So I still want you to try out this question before we go through it, but we should probably identify a couple of parameters first. So really, we should let the first integer equal x. Okay, now notice it says two consecutive integers here, so that means that the second integer must be x plus 1, right? Two consecutive integers, so this is 5, 5 and 1 make 6, so then the second integer is 1 higher than the first. So from there, now we need to understand this idea of what a reciprocal is. So a reciprocal, if I had 5, its reciprocal is 1/5. If I had 8, its reciprocal is 1/8. So if I have x, its reciprocal is 1 over x. So using that idea, we should now have enough information for you to try to solve out this question. So again, I encourage you to kind of pause the video, give it a try, and come back when you're ready. Alright, so we have our given information above. So let's start off. We've got two consecutive integers that are here, and they're talking about the sum of the reciprocals. So remember, sum just means addition, and it's saying that these two reciprocal integers added together totals 11 over 30. So we have 1 over x plus 1 over x plus 1 has to equal 11 over 30. And from here, I can see that, okay, I've got reciprocals of consecutive integers, they're being added together, that's their sum, equals 11 over 30. So then I need to figure out and solve for x. And then right away here, we can also say, okay, I can see that x can't be 0, and it looks like it can't be -1. So x can't be 0, and x also can't be -1. Okay, and just kind of give myself a little bit of space to write here. Alright, so let's start to solve for this. So the same way that we did before, I'm going to multiply by x to start. And the reason why I'm going to do that is because I want to eliminate the x on the bottom in the denominator spot. So if I multiply by x everywhere here, I can see that x over x gives me 1. So that's the whole purpose for doing that step. Okay, it just gets rid of the denominator in that part. And then from there, then I can write out what I have left. So I have 1 plus, and then 1 times x is just x, over x plus 1 equals 11x over 30. Now I'm going to go through and do the same thing again, and this time we're going to multiply by x plus 1. So multiply by x plus 1 on each term, x plus 1 and x plus 1. Here I can see that my x plus 1s are going to cancel. Again, reason for doing that step. And then after that, I can see that I have 1 times x plus 1, so that's just x plus 1, plus, now I just have an x left here, equals 11x times x plus 1 all over 30. And then the last step that I need to go through and do is I need to multiply by 30 everywhere. And so hopefully you're starting to see a pattern here that I'm really just picking a denominator and I'm multiplying it on every term. You can certainly do multiple steps at once if you wanted to. I'm just doing them one at a time just to try to make it as clear as I can. So multiplying this, now all the way through, I've got 30 and x plus 1 plus 30x is equal to, and then now the 30s have canceled here, so it's just 11 times x plus 1. So now let's start to expand this out. Looks like I have 30x plus 30 plus 30x is equal to, and then x times x is x squared, so times that by 11, so it looks like I have 11x squared, and then 11x times 1 looks like it's just 11x. So now I'm going to combine my x terms together. Looks like I have 60x plus 30 is equal to 11x squared plus 11x. And then I'm going to have to combine all my terms together because I have a squared term here. So that squared term, really, it's positive on the right-hand side, so I'm going to keep it there, which means I'm going to move my 60x and my 30 over to the right-hand side so I can combine all my terms together. So 0 equals 11x squared plus 11x minus 60x minus 30. Now combine my like terms together. 11x squared, I've got 11x minus 60x, it looks like minus 49x, and then minus 30 left over at the end. So this one doesn't go in evenly into anything, so it becomes a type 2 trinomial. So I need to think of two things that can multiply to give me the a times c term, so 11 times negative 30. So two things that multiply here to give me negative 330, and those same two numbers are going to add to give me negative 49. And really, I can see that the separation here, negative 49, that's a fairly large separation. So it's probably not two numbers that are incredibly close together. So then I would just start trying to see what goes into each value and come up with my numbers like that. So if you're at this step, pause the video and give it a try and see if you can come up with those like denominators. Alright, so if you've had a chance to plug them in, hopefully you're coming up with a value that is negative 55 and 6. Okay, and again, it's really just kind of going through a trial and error type method where you're plugging in numbers so you can see what works for both of these conditions. So then 0 equals 11x squared minus 55x plus 6x minus 30. 0 equals, now I'm going to group together my first two terms and my last two terms. See what I end up with. Looks like I can take an 11 out of the first part and an x, and I'm left with x minus 5. And looks like in the second part I can take out a 6, which also leaves me with x minus 5. So that means that 0 is equal to 11x plus 6, right? That's what's left over here and here, so 11x plus 6. And then my common factor there is x minus 5. So now if I want to solve for this, I can see x minus 5 is going to equal 0, which means that x needs to equal 5. And on this side, I can see that 11x plus 6 equals 0. So that would mean then that 11x would equal negative 6, or x would equal negative 6 over 11. So I have two possible answers here. Now the thing with this question is it said integers. So that means that this one is actually not an answer. It's called an extraneous root. It just means that it's extra in the problem. It doesn't fit the context of the question. It's a valid solution to the problem, but it doesn't fit the context of what the word problem is that it's giving us. So then after that, we need to go through and we need to check this. So we have x is equal to 5 as a potential answer, so we need to go through and we need to check x is equal to 5, because this one is an extraneous root, so it's not an answer to what we're looking for. So let's check this out. So if I check this out, I have 1 over 5 plus 1 over 5 plus 1. Does that equal 11 over 30? Well, it's 1 over 5 plus 1 over 6. Okay, so 1 over 5 plus 1 over 6, does that equal 11 over 30? So I'm going to have to multiply, in terms of coming up with common denominators here, the first common denominator is 30. So this is going to have to be multiplied by 6, and this one's going to have to be multiplied by 5 to make that common denominator. So both terms, 5 on the top, 5 on the bottom, and in this case I can get 6 over 30. All I'm doing here is adding fractions. 6 over 30 plus 5 over 30, does that equal 11 over 30? Now I have a common denominator, so we can say 11 over 30 is equal to 11 over 30, and I can see that this checks out. So x is equal to 5 is a correct answer under the conditions that x cannot equal 0 and -1. So that one's a bit bigger of a problem to go through just because of the steps that we had to follow in order to check and see, but it also led to this idea of this new term with an extraneous root. It's a root that is could be a valid solution to the question, but it doesn't have context in there for the problem. So I'm going to pause this video at this point and pick up in part 3 as we start to carry forward with these equations and solving equations.